Okay, Cindy, the videographer, like it. And the assistant videographer. Okay. I didn't say that, you said that. Okay. The next time somebody calls you a fathead, what do you say?
Thank you.
Thank you very much, because your brain is made of
fat.
Is made of fat. Excellent. So first video, 8th grade science, chapter 1, kind of like a pre-unit video, which counts. I'll give you quizzes on this. I'll make sure I go slowly. We've done some of this before, correct? Yes or no? Yesterday, but what I'm going to do is I'm going to review what I did quickly and then continue and try to get through this. We have like 10 minutes left. I'll try to get through some of this, okay? First video, we're cool, we're still online, we're still going. Building some aircrafts there, buddy? Excellent. No, of course not. Okay, good. Okay. All right, now, so scale A, B, C, D, E. I have the top one is going to be A. This is going to be B. So we have A, B, C, D, E, and then I have A, B, A, B, A, B, A, B. There's going to be 10 measurements. Now, the first thing you have to do, and we did this yesterday, is determine the precision. What's the precision? Precision is the uncertainty, is the estimation. Now, let's go through this slowly, because there's going to be another class that's looking at this as well. Clear? Okay. We have to start with place value, correct? Now, we reviewed place value, and that's something that you've known for years, place value, correct? Okay. We'll start with millions, okay? And we're going to go down. We're going to what's less than millions, okay? We're at millions. One less than millions is 100,000s. 10,000s. 100, thousands. Hundreds. Tens. Ones. Follow me. Tens. Hundreds. Thousands. 10,000s. 100,000s. Millions. Right? You get it? So it starts over here with millions. It can go higher, billions, millions, 100,000s to millions. Correct? Yes or no?
Yes.
First thing. Second thing. We know scale A we're going to look at first. Scale A goes from 10 to 20. What would the next one be? 30, right? 40, 50, right? So let's write that down. So it's going to go 10 or 0, 20, 30, 40, 50, correct? What place value is changing? Tens. So that's tens place, correct? Yes? Now let's look at this. 10, 11, 12, 13,
14, 15.
All right, let's write that down. What place value is changing?
Ones.
Ones. Right? So that's ones. Okay, now. This twilight zone, this area here, isn't that an estimation? Well, let me demonstrate. Because you've all done this before and you're not realizing that it's an estimation, okay? You don't realize it. Let's do that one right there. What's that measurement? Do you know?
15.5.
How'd you do that so quickly? Estimation. So you're saying that that's 15.5. What's that 0.5 mean?
Precision.
No, but what does it mean? What are you suggesting?
It's around.
It's around, but what are you suggesting? Why are you saying 0.5?
Exactly there.
Well, what are you saying? This is going to be 15. That's going to be 16. So you're saying it's about, may I speak for you? As if I'm taking over your brain. You're actually thinking this. You're saying that it's 15 and a half, right? Or 15.5, right? So what you did, you automatically estimated that it's right in the middle there. Now let me ask you this. What place value is the estimation?
10.
Tenths. You almost didn't even realize that it was tenths because you did it so naturally, didn't you? You did it so naturally. All right, write this down. Cindy, you don't have to write this down, but write this down, everybody. You ready? Watch me up here. Watch me up here as you write this. Watch me up here as you write this. Okay, are you ready? Watch me up here as you write this. Okay, you ready? All right. The estimated place value here or here is the place value that is one place value less than the place value represented by the smallest graduations. The estimated place value, right here, this estimated place value, is the place value that's one less than the place value, look up here, the place value represented by these small gradations. Remember we did that right here? What place value is represented by these gradations? Remember? 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What place value is represented by the smallest gradations?
1.
Ones. Very good. What's one less than ones?
10.
Tenths. That's the estimation. Do you know what you call that? It's the precision. International Baccalaureate chemistry books, science books, American, they often use the word uncertainty. They'll also use precision, but that's what precision is. Precision is a number. It's not just an idea. It's not just an idea. We'll talk about the idea of precision. But precision is actually a number. It's a number. What's the number in this case? You said it.
10.
Tenths. So how do you write that? How do you write that?
0.1.
That's it. You write tenths. Use the number 1. Yeah. And the number 1 is in the place value that's occupied by tenths. Clear? You get it? So what would this one be? What would that measurement be? 14?
1.0.
Yeah. Is that 0? Now listen carefully. Is that 0 read from the scale? Is it? Let me try to fool you. You ready? Does 14 equal 14.0 mathematically?
Yes.
It does. Okay, good. Is that 0 important?
Yes, it is.
No.
Yes, because mathematically they're equal. Scientifically they're not. Is that 0 written from the scale? Let me ask you the question another way. I have everyone's attention. It's unbelievable. Let me ask you this. Is that 0 within the range of precision for that scale?
Yes.
Yes, it is. The precision is 0.1 and it's tenths place, and that is in tenths place. So is it written from the scale?
Yes, it is.
Yeah, it is. It is. Now you're asking me, well, when isn't it? 2 more scales, we'll see that. Okay? Can we move a little bit faster? Because this is kind of a little bit of a review, sort of. What's the precision here? You ready? 100, 200, 300, 400, 500. What place value is changing?
Hundreds.
Hundreds, good. Excellent. 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. What place value is changing?
Yes.
Tens. What place value is 1 less than tens? Ones. Hey, look, that's this area, right? Right? Let's double check, okay? What's this value here?
155.
Is that right? Estimated, this is 150, 160, 155. Sounds good?
Yeah.
You can always test, but what's the precision?
Point.
Ones. I know you're wondering, how do you write ones place? Right? That's what you're saying, right? Well, how do I write ones? Is that 1 in ones place? Yeah. Yeah. If I write, is that in ones place? Of course it is. Is that in ones place?
Yes.
Of course it is. Okay, now, what's this one? Now, let me ask you this. Is that 0 read from the instrument? Yes, it is, because it's in ones place. So it is within the precision, isn't it? So you don't know this, but there is a convention, and I'm going to tell you what the convention is. This is just a point of knowledge. This isn't really thinking. If you have a 0 in ones place and no other zeros, and that 0 is written from the instrument, you got to put a point there. Okay? Yeah.
So does that mean you moved the decimal?
No, I didn't move the decimal. Decimal was there. The decimal is understood to be there, right? I just put it in. I know it's really weird. Just hang with it, okay? It will become clearer after the next example. It will be. Trust me, it will be. I've been doing this for years and years and years and years and years and years and years. And everybody's about halfway there when I do that, and they say, all right, I can deal with that. Not really, but all right, I'll give them the benefit of the doubt. And then when I do the next example, you know what everybody says? Okay. All right. Good. You got it? You all right with it? All right. Just let me do the next example when we're done, okay? And then we'll quit the thing, okay? Can you give me like 30 seconds? Okay, fine. Okay. So what's this one? Okay. Thousands.
2,000. 3,000.
Oh, so what place value is changing? Thousands. What's this one? Hundreds. Good. What's one less than hundreds? Tens. So the precision is tens, right? What's this value here?